Hello students, welcome to lesson 14 on trigonometry. I hope you are all doing well. Good. In our previous lesson, we looked at special right angle triangles, and we saw that special right angle triangles are right angle triangles with 30, 60, 90 and 45, 45, 90 as interior angles. So this is how they look like. This one is the 30, 60, 90 and this one is the 45, 45, 90. Then we looked at why they are special. So we said they are special because they have a special relationship between the sides. So their sides has a special relationship. Okay, so we then looked at this relationship. So we first of all looked at the relationship between the sides of the 30, 60, 90 right angle triangle. So this is what we did. So we saw that with the 30, 60, 90 right angle triangle, if the smallest side is x, then to get the hypotenuse, you have to multiply the smallest side by what? By 2. So if the smallest side, that is the side opposite the 30 degrees, is x, then to get the hypotenuse, you have to multiply the smallest side by what? By 2. So we also looked at how to get the adjacent, that is the perpendicular height here. So we saw that the adjacent side to the 30-degree angle is gotten by multiplying the smallest side by √3. Okay, so basically if you know the smallest side, you can get the other two sides. So the smaller side, if it is x, then the hypotenuse will be what? Twice the what? The x. And then the adjacent will be what? √3 times what? The x. Good. We also saw that, or we looked at the fact that we get this from an equilateral triangle. So the 30, 60, 90 right angle triangle is derived from what? An equilateral triangle. An equilateral triangle. Good. So we moved on to the relationship between the 45, 45, 90 right angle triangle. There also we saw that if we know one of the sides apart from the hypotenuse, okay, if we know one of the sides apart from the hypotenuse, we can get the other two sides. So this side, if it is x, then this other side will also be x, and then the hypotenuse will be √2 times the x. Okay, so we saw that if one side is x, then to get the hypotenuse, you have to multiply the one side by what? By √2. So x by √2 will give you what? The hypotenuse. So we also saw that it is an isosceles what? Right angle what? Triangle. So it is isosceles because two of the interior angles are what? Are equal. So if two of the interior angles are equal, that means that the sides, two of the sides will also what? Be equal. So that is why if this is x, this is also what? X. Good. So basically that is what we looked at the last time we met. So we don't need to go through Pythagoras theorem to get the sides of what? Of the special right angle triangles. Their relationship between the sides will let us what? Get it. So if you know that this is x, the hypotenuse is straight away x √2. I hope you are okay. Good. Now in this lesson, we'll be looking at the trigonometric ratios of special angles. So our lesson today will focus on trigonometric ratios of special angles. So the special angles here are the 30 degrees, the 60 degrees, and the 45 degrees angles in the what? The right angle triangles that we've just looked at. So the special angles here, we are referring to the 30 degrees, the 60 degrees, and the 45 degrees angles in what? A special right angle triangle. Good. So let's look at it. Let's look at it. Good. So trigonometric ratios of special angles. So we are looking at the 30 degrees, the 60 degrees, and the what? The 45 degrees. Good. So we'll begin with the 30 degrees. So from the 30, 60, 90 right angle triangle, we've seen that if this is x, this will be what? 2x, and then this will be what? X root 3. Good. So now we are okay, or we are conversant with the trig ratios. So now find sine 30. Find sine 30 for me using this special right angle triangle. Good. So sine 30 degrees, we know will be what? Opposite over what? Hypotenuse. So the opposite is what? X. And then the hypotenuse is what? 2x. So when you simplify, the x here will cancel the x here. So it means that we are going to get 1 over what? Over 2. So what it means is that sine 30 degrees is always 1 over 2. So you have to keep this one in mind. That is the exact value of what? Sine 30. Sine 30 degrees is always 1 over 2. I hope you get it. Good. Now, so this goes here 1, goes here 1. Good. So now find sine. So no, sorry. Let's deal with the sine first. Find cos 30 degrees. Find cos 30 degrees. Find cos 30 degrees. Good. So cos 30 degrees will be equal to, we know that cos is what? Adjacent over hypotenuse. So the adjacent here is what? Is x root 3. So you write your x root 3. And then the hypotenuse is what? 2x. So you write your 2x. Now, this one also, when you simplify, the x here will cancel the x here. So we are now going to have root 3 on 2. Root 3 on 2. So what it means is that cos 30 degrees is always root 3 on 2. So the exact value of cos 30 degrees is root 3 on 2. Good. Now, last one. Find tan 30 degrees. Find tan 30 degrees. Good. So tan 30 degrees, we know tan is what? Opposite over adjacent. So what's the opposite? The opposite to the 30 degree angle is x, and then the adjacent is what? X root 3. So you write your x divided by your x root 3. Good. Now this x will cancel this x. So you are now going to have 1 over root what? Root 3. And we've seen this before. We saw that anytime you have a fraction where the denominator is an irrational number, you have to what? Rationalize the denominator. So we rationalize the denominator by multiplying the numerator by what? By root 3, and the denominator also by what? By root 3. So that we get a rational number for the what? For the denominator. So this one is going to give us root 3 on what? On 3. Because root 3 times root 3 will give us what? Give us 3. Good. So this is the trig ratios for what? For 30 degree angle from the what? The special right angle triangle. So sine 30 is always half, that is 1 over 2. Cos 30 is always what? Root 3 on 2. And then tan 30 is what? Root 3 on 3. Okay, good. Root 3 on 3. Now we can get this value from using the calculator, okay? But we are not using the calculator. This concept will also help us to get the exact value of what? Of trig ratio for the special angle. That is why we don't need calculator now. So even in exams, if you don't have calculator, you can derive sine 30 from this special right angle triangle. You can derive cos 30 from this special right angle triangle, and you can derive tan 30 from what? This special right angle triangle. So without using calculator, you can get the sine, the cosine, and then the tangent of the what? The special right angle triangle. So even this one also makes them special. Good. So now let's look at the 60-degree one. Good. So find sine 60 from this diagram. Find sine 60. Sine 60. Good. So we know that sine 60 degrees is what? Opposite over what? Hypotenuse. So sine is opposite over hypotenuse. So what is the opposite to the 60-degree angle? We have what? X root 3 divided by, what is the hypotenuse? 2x. So we have our 2x. So now when we simplify, this x will cancel this x. So we are going to have root 3 on what? On 2. Okay, root 3 on 2. Good. Now find cos 60. Cos 60 degrees. Cos 60 degrees. Good. So cos 60 degrees, we know cos is what? Adjacent over what? Hypotenuse. So the adjacent to the 60 degrees is what? X. So you write your x. And then your hypotenuse is what? 2x. So you write 2x. So now simplifying, this x will cancel this x. So you are going to have 1 over what? Over 2. So cos 60 degrees is always 1 over 2. And then sine 60 degrees is always root 3 on 2. So you keep these ones in mind. Good. Then finally, tan 60. Look for tan 60. Tan 60 degrees. Good. So tan 60 degrees, tan is what? Opposite over adjacent. So opposite is what? X root 3. Adjacent is what? X. So you write your x root 3 over what? Over x. So now this x will cancel this x. So you are going to have root 3 on 1, which is the same as what? Root 3. So tan 60 degrees is root 3. Good. So students, this is the trig ratios of the 30-60 special angle. Now we'll look at something. You see, the sine 30 degrees, we got what? Half. Okay, good. So sine 30 is half. Now, what is cos 60? You see that cos 60 is also what? It's also half. So what do you remember about this relation? We got sine 30 to be half, cos 60 also half. Why? Why do you think they are having the same value? It's because they are what? The 30 and the 60 are what? Complementary angles. So we saw in our previous lessons that the sine of an angle is the same as the cosine of an angle if and only if the sum of the two angles are what? Are complementary. So unless the sum is 90 degrees, they cannot be equal. So sine of an angle will always be cosine of another angle if and only if the angles are what? Are complementary. So 30 and 60, they are complementary. That is why the sine of 30 is giving us the same value as what? The cosine of what? Of 60. I hope you are clear. Good. So let's move on. Let's move on. Let's move on. Good. So now I want to look at the trig ratio of the special angle. So this time we'll focus on the 45-degree one. 45 degrees. The 45 degrees one. Good. The 45 degrees one. So the same concept. Find sine 45. Sine 45 degrees. So sine 45 degrees, we know sine is what? opposite over hypotenuse. So you can pick any of the side because they have the same value. So opposite will be x, then the hypotenuse is what? X root 2. So this will cancel this. We are having 1 over root 2. But we have to what? We have to rationalize. So we multiply this one by root 2 over this one by what? By root 2. And this is going to give us root 2 on 2. So what it means is that sine 45 degrees is what? Root 2 on 2. What of cos 45? Cos 45. Find cos 45 degrees. So cos 45 degrees, cos is what? Adjacent over what? Hypotenuse. So the adjacent can be any of them, which is x. Okay? Then our hypotenuse is what? X root 2. So we are getting the same thing. This will cancel this. We have 1 over root 2. We rationalize. Okay? And then we are getting root 2 on 2. Root 2 on 2. Last one. Tan 45. Tan 45. Tan 45 degrees. So tan is what? Opposite over what? Adjacent. So if you are using this 45 degrees, the opposite is x, the adjacent is what? X. So we are going to get x over x. And then this x will cancel this one. Okay, so we are going to have 1 over 1. And this will give us what? 1. So tan 45 degrees is what? Is 1. Cos 45 degrees is what? Root 2 on 2. And then sine 45 degrees is what? Root 2 on 2. So why do you think this is so? Sine 45 is the same as what? Cos 45. So the reason is that what? 45 and 45 are what? Complementary angles. So when you have complementary angles, then sine of that angle will always be equal to what? The cosine of the other angle. Right. So students, that is all about the trig ratios of special angles. So we need to summarize these ones and then we keep them in mind. So you should know that always sine 30 degrees is what? Half. Always sine 60 degrees is what? Root 3 on 2. Always tan 30 degrees will be what? Will be root 3 on 3. Root 3 on 3. Then we looked at the 60. Sine 60 is what? Is the same as what? Cos 30. Okay, sine 60 is the same as cos 30. I hope you are with me. Good. So sine 60 is the same as cos 30. Therefore, sine 60 will be what? Root 3 on 2. Cos 60 is the same as sine 30. Therefore, cos 60 will be what? 1 over 2. And then we saw tan 60 to be what? To be root 3. So, sine 45 root 2 on 2, cos 45 root 2 on 2, and tan 45, 1. Good. So let's summarize it. Let's summarize it. Good. Let's summarize it. Right. So, we have this table. This column has the degrees of the special angles, and then this side is what? The ratios, the trig ratios. So sine theta degrees, so which is sine 30. So sine of 30, we said it is what? It is half. 1 on 2. So sine 30 is half. Then what of cos 30? We got cos 30 to be what? Root 3 on 2. Root 3 on 2. And then tan 30. Tan 30, we got it to be what? Root 3 on 3. Okay, root 3 on 3. Good. Then 45. So sine 45, we got what? Root 2 on 2. Then cos 45, it's also the same thing. So we are getting root 2 on 2. And then tan 45, we got what? 1. Now fill the last three. Fill the last three for me. Fill the last 3 for me. Fill the last 3 for me. Good. Good. So we can get the last 3 even without doing any thinking about what their values. We can get it from what? From the 30. Because we know that sine 30 is the same as what? Cos 60. Because 30 and 60 are what? Complementary. So sine 30 is what? Half. So it means that cos 60 will also be what? Half. So I'll put my half here. Then I also know that sine 60 is the same as what? Cos 30. So if cos 30 is root 3 on 2, then my sine 60 is going to be what? Root 3 on 2. Okay, then tan 60, we found it to be what? Root 3. So we can also get it from the ratio of sine theta and cos theta, because we saw that tan theta is the same as sine theta over what? Over cos theta. So tan 60 is the same as what? Sine and tan 60 will be the same as what? Sine 60 over what? Cos 60. So what is sine 60? Sine 60, we are getting what? Root 3 on 2. Okay, then what is cos 60? Cos 60, we are getting what? Half. Okay, so when you divide this one by this one, okay, we are going to get what? Root 3. Root 3. So this is root 3. So students, these are the exact values of the trig ratios of the special angles. So you have to keep all these values in mind. Without calculators, you can derive it yourself. With calculators, you can also derive it. But we'll need this concept in our further studies in our trigonometry. That is why we are going through all this. Ideally, we can use calculator, but there will be a concept ahead of us that will derive or will need the idea of what we've just done to help us understand it. Okay, good. So if you want to test with calculator, let's see how it goes. Good. So you have this sine 30. So you punch the sine. You punch your 30. Then you close the bracket. Equal to. So the calculator is giving us what? Half. So it means we are right. Good. Now sine cos 30. So you punch cos. You punch 30. You close the bracket. Then equal to. It's what? Root 3 on 2. Good. It means that we are correct. I love this. Then last one. Tan 30. Tan 30. Tan 30. Tan 30 equal to root 3 on 3. Bravo! We are there. So you see, you can use your calculators to test it, to see whether you are right or not. Right. So students, this is where we'll end. Till we meet again, revise, read ahead. Bye.